So just to begin, Mike, so what exact area of expertise in manufacturing?
So, as you can tell, I've been around for a few years. I started in IT and then and materials in a manufacturing environment. Then I went into management consulting and then into ERP for a number of years and then into MES MOM. And I've been focused on the MES MOM space for the last 20 plus years, primarily in the transportation and mobility and industrial equipment areas. But I've also worked in other industries. And my focus for many years was tech sales and implementations, both so post and pre-sales implementation. But the last few years, I've done some work in our Delmia Center of Excellence, and I'm actually now in a marketing role just for the last 2 years or so.
Okay, so would you say that your job with Dassault has been kind of talking about its various softwares and maybe talking to potential customers about, okay, what could fit best for them?
Yeah, absolutely. That in particular for potential customers, but also for existing customers. Where could you be using the software better? What are issues that you're having that we can help you address? Those sorts of things. So yeah, a lot of direct customer contact for mostly direct customer contact for, goodness, the last 20 years, 23 years.
Okay, and so since Dassault is not necessarily a household name, let's begin with that. So what exactly is Dassault Systems, and what is their field of expertise?
Okay. It's a great question, especially in the U.S. In Europe, people tend to know the Dassault name better. Dassault is actually the eighth or ninth largest software company in the world. And we like to say we take companies from ideation to execution. They started about 40 years ago with a product that a lot of people are familiar with, that is CATIA. So started with 3D modeling, CAD, CAM, that sort of thing, and they've expanded from there. They now have a portfolio of 14 different brands, everything from CATIA and SolidWorks on the engineering and design side to Delmia, where I'm focused, which is more the manufacturing part, where we do things like take the E-BOM and convert it to an M-BOM, define all the resources required to do production, do simulation of products, product lines, plants, facilities, processes to ensure you've got the most efficient and effective process before you even physically start to perform the process or to set up the product line, right down to the execution pieces, which is where I primarily focus. We also do simulation for design, and so our expertise is very broad. And we also have a significant planning and optimization capability, as well as significant analytics and data analytics and big data capabilities, and a lot of collaboration capabilities. So the 14 brands do cover a very broad spectrum of capabilities.
And since Dassault is known for their virtualization and 3D modeling and so forth, what exactly are they trying to accomplish specifically with the Delmia brand, and what can be the expected value of said brand with manufacturing?
There's significant value. They're using what we call the virtual twin. You hear a lot about the digital twin in industry, and we talk a lot about the virtual twin because we've really taken what industry defines as a digital twin and extended it. Digital twin tends to be single purpose. Virtual twin is multi-purposed and ties multiple digital twins together. Digital twins tend to be relatively fixed. Virtual twins are very flexible, so they can change and grow as the situation changes and as more information comes in. And digital twins are three-dimensional. Virtual twins, we add a fourth dimension, that being the dimension of time. So that virtual twin capability provides value throughout manufacturing, from the start of manufacturing, where you're building your M-BOM and your process plans and that sort of thing, because we do something called model-based systems engineering instead of file-based engineering. When you're working on a 3D model in CATIA or SolidWorks, it resides on the 3D Experience platform. When I begin developing an M-bomb and a process plan to use that E-bomb, I'm looking at working with the exact same model. It's not like I take a file and give it to the next guy who gives it to the next guy. It's a single model that everyone works from. So it is inherently collaborative, and changes become much more fast and effective because you're collaborating, and because when they make a change to the 3D model, it's immediately visible because you're all working from the same model. So that's one advantage. The next advantage is when you do get into the process planning piece, the ability to simulate everything from an individual part, an individual operator and the ergonomics of their job, an individual robot and how that robot works, starting at that level of detail all the way up to a full plant and every line in the plant, and are the lines laid out most effectively and efficiently. It's a huge time and cost saver, both for new plants, for new product introduction, and as well as for product updates and engineering changes. Because again, you can simulate first, identify issues, make those corrections, simulate again, and continue that process until you've got the most effective simulation model to work from. And so that then when you get to the physical part, you've solved a lot of the problems already, which saves, again, time and money. I'll give you one specific example. We had a customer who was setting up a robotic assembly line. So 4 robots, each with a pallet of materials that they would pull from and put on the line. And they had laid this all out in a 2D CAD model. And we went to them and said, hey, let us virtualize it. Let us bring our partner in to do a virtual twin of the facility itself. We've got virtual twin models of the robots. We can model the whole thing to make sure that it's effective. And their first response was, well, we don't need it. We can see that it works. And we talked them into letting us try. And it turns out one of the robots could only reach about 1/3 of the pallet with the materials on it that that robot needed. Had they not done virtualization first, they would have built the line out according to that model, and they wouldn't have discovered they had a problem until they started running the line. They couldn't reach the materials necessary to do the production, which means they would have had to reconfigure the line, stop production, reconfigure the line, figure out how to fix that, hopefully without moving all 4 robots. By identifying it through simulation first, we were able to make some adjustments to how they had the line and the pallets and everything set up, and simulated it. It worked effectively in a simulation environment. Then when they went to the physical environment, it was also effective and worked as simulated. So it saved them a significant amount of time and effort and cost. And then at the execution end, by being able to take the process plan, the M-bomb, the work instructions, the quality data collects, and directly import those into the execution side, you know that the production people are seeing and using and doing what was intended when the process plan, the M-bomb, and those things were created. And now we can feed back. So if there's consistently a part that gets replaced or consistently a change that has to be made in manufacturing, we've got that inherent feedback loop now so that we can then make adjustments to the model, make adjustments to the process plan, to the tooling, to whatever needs to be adjusted. But we can do that. We've got that constant feedback loop working from a single model, so it makes ongoing changes much faster and much more effective as well. So that full digital thread, again, we say from ideation to execution, that full digital thread has real value at every step in the process.